Welcome to the Introduction to the Brain Visualizer tutorial. In this tutorial, you will learn what FEAGI Brain Visualizer is, its purpose, layout, and basic operations. FEAGI is a powerful neuron simulation framework enabling you to build brains for robots and beyond. The Brain Visualizer is a tool that enables you to gain real-time insights into a FEAGI brain. You can visualize brain structures in 3D and view neuronal activities within them, create brain structures and modify their properties, create cortical mappings to rewire the brain, develop neural circuits and assemble them like Lego building blocks, inspect properties of each brain component, and much more. You can access Brain Visualizer through the NeuroRobotics Studio dashboard. Visit Intro to NeuroRobotics Studio to learn more about it. The Brain Visualizer consists of a main toolbar along with two distinct workspaces, the 3D Brain Monitor and the Circuit Builder. We will explain each workspace in detail shortly. The main toolbar allows you to view and add circuits, view and add specialized input/output areas, view and add connectivity rules, access workspace tools, and monitor brain statistics. To adjust the text size to your liking, you can use the widget on the top right. Before we learn about additional tools, let's review what a FEAGI brain is made of. A FEAGI brain, inspired by the biological brain, consists of many functional building blocks that includes cortical areas, which are spatial structures that contain spiking neurons acting as a computational building block. Cortical areas, which are called areas for short, can be a different type that includes input, output, core, interconnect, and memory. Connectivity rules are a collection of rules that define how cortical areas project to each other and enable neurons from a source area to find its destination. Cortical mappings are the wiring between different cortical areas that leverage connectivity rules. Neural circuits are a collection of cortical areas and the mappings amongst them that is purpose-built for an application. A neural circuit typically consists of an input, an output, and interconnected cortical areas. To learn more about each of these topics, please visit its dedicated tutorial. Now to dive into the Brain Visualizer workspaces. As noted before, the Brain Visualizer consists of two major workspaces, the 3D Brain Monitor and the Circuit Builder. The 3D Brain Monitor is an interactive 3D environment that enables you to visualize cortical areas, cortical mappings, and real-time neuron activities in 3D. This view is optimal for designing and testing a neural circuit. The 3D Brain Monitor is based on a Cartesian coordinate system with the 0, 0, 0 coordinate located right where the 3D XYZ arrows meet. You can navigate the 3D scene by clicking and dragging your mouse and using arrow keys. For detailed information, please visit the navigation section of the user guide. Circuit Builder is an interactive 2D environment that enables you to view, build, or modify neural circuit schematics. This view is optimal for documenting and sharing your circuit design with your peers. You can click and drag the scene to view your entire network. At the bottom right section of your Circuit Builder, there's a small preview window that allows you to quickly scan your entire network. As a pro tip, your 2D circuit can become messy fast. Use the rearrange icon on the Circuit Builder toolbar to automatically organize your circuit. Be aware though that this will rearrange all your areas, so please use caution with it. Now to dive into the toolbar components. Each workspace in the Brain Visualizer has its own dedicated toolbar. When you launch the Brain Visualizer, you can spot the main toolbar on the top of the screen. It consists of three main segments. The first segment is the component that enables you to view or add circuits and circuit components. Clicking in the component name will open a drop-down list of all associated components. For example, you can click on the inputs to view the list of all existing input cortical areas in your brain. Each component has a plus icon, which by clicking on, you can add that type of component to your circuit. For example, clicking on the plus icon to the right of the outputs will open a dialog that lists all output area options, allowing you to select and add one to your circuit. A connectivity rule is a collection of parameters that defines how neurons from a source cortical area can find their destinations. Vectors leverage geometric vector definition to define the mapping, while pattern types leverage wildcards and targeted selections. The second segment is the workspace tools. providing various tools for you to interact and modify the behavior of your workspace. The first icon from the left provides view options, allowing you to switch between various split view formats, including Circuit Builder, 3D Brain Monitor, Vertical Split View, and a Horizontal Split View. The magnifier icon is called Inspectors, a collection of powerful tools enabling you to gain insight into the inner workings of your circuit. The Director Chair helps you build camera animations, a tool which can help you build attractive presentations of your circuit. The Animation Controller allows you to play, pause, and reset the animation. The Info icon is the user guide where you can learn details about all Brain Visualizer features and functions. The Gear icon contains the Brain Visualizer settings. The third and last segment of the toolbar is Neural Stats. This segment allows you to view and edit the system frequency, which controls how fast it can process information. It also displays live counts of the total number of neuron and synapses in the entire brain. Each FEAGI brain consists of a main circuit and additional subcircuits. A circuit is a collection of cortical areas and the cortical mappings connecting them together. The main circuit is the first thing you see when launching the Brain Visualizer. This is where all the input and output cortical areas are located at. In other words, this is your peripheral nervous system where your FEAGI brain interfaces with the outside world. You can click on the input and output buttons on the top toolbar to view the list of all such areas in your circuit. You can also use the plus button to add new ones. Each FEAGI brain contains a set of core cortical areas that come standard with all circuits. They are located in front of the XYZ axis coordinates sitting on a plate. This most important one is the power area, which is the form of the cone. The flashing frequency of this area highlights the brain frequency, which you can set on the stats segment of the toolbar. To learn more about the core cortical areas, visit the user guide or the associated video tutorial. To build your own neural circuit, click on the plus button on the right side of the circuits button on top of the toolbar. After naming and positioning the circuit, you will see empty plates for this circuit appear in your brain monitor. The left plate will house your circuit's input areas, and the right one will host the output areas. To add components to your circuit, you will need to click on one of the plates and then click on the second icon, Open Circuit in 3D tab. This will open the split view where you can see the internals of your circuit in a dedicated brain monitor tab. You will be able to add a sub-circuit, interconnect areas, or memory areas to your circuit. To add an interconnect area, simply click on the plus icon beside the Interconnect Areas button and by choosing its name, position, and dimensions. You can clone your cortical area to quickly replicate it by clicking on the area and clicking on the Clone Cortical Area icon. You can wire cortical areas using the Quick Connect feature. Let's wire the power area to one of our interconnect areas. To do so, click on the power area, click on the Quick Connect, then click on your newly created cortical area. Lastly, pick a connectivity rule from the list. We recommend you use a projector while starting. You can learn more about how to build your own connectivity rule and the difference between them in the associated tutorial. This was an introductory tutorial to get you started with the Brain Visualizer. There is much more you can do, including editing neuron properties, building advanced connectivity rules, and beyond. Please watch the other tutorials to learn more.